This is the homework helper for Chapter 4, Section 8 in the 8th grade workbook, Pythagorean Theorem. Alright, so let's go ahead and take a look at the first set of questions here. In the first three questions, the idea is the same. In all of these questions here, you're finding C, which is the hypotenuse. Remember, what the theorem states is that we can square the length of the legs, and that's equivalent to the length of the hypotenuse squared. So let's just go ahead and pick one of those questions, and I'm going to pick the one that looks like it could be the nastiest, which is question number 2, because it's got the decimals in there. So remember, the two sides that make up the right angle are called the legs. And clearly, these two do make the right angle. Again, we know in this particular question, we're finding C, the hypotenuse, as is true with all of these. So in every one of these questions, they've given us the legs. So the formula says I'm going to take the lengths of the legs and square them. So I'm going to take 8.4 and square it, and I'm going to take 6.3 and square it. And it says I'm supposed to sum those, which is why I put an addition sign in the middle. So when I take 8.4 and square it, the result is 70.56. And when I take 6.3 and square it, the result is 39.69. So I'm going to go ahead and add those together. 70.56 plus 39.69 is going to change into 110.25. Now that is equal to this hypotenuse squared. The thing is, if we look at what the hypotenuse is actually labeled on the triangle, the hypotenuse is just labeled C. So to get from C squared to C, which is where my final answer is going to go, I have to undo that squared part, cancel it out. Well, remember, squares and square roots are opposites of each other, which is what this chapter has been about. So to get from C squared back to C, I'm going to take the square root. And of course, because I'm manipulating an equation, if I do it to that side, I have to do the same thing to the other side of the equation. So when I take the square root of 110.25, the result is 10.5. So C, this hypotenuse in question number 2, must measure 10.5 units. All right, let's go and take a look at 4, 5, and 6. Now, 4, 5, and 6, we're still using the theorem. That's not the question. But what's different here is they're not always having us find the hypotenuse. Sometimes they might be having us find one of the legs. You know that based on simply how the triangles are labeled. If what they have labeled there is A or B, you're finding one of the legs. If what they have you finding there is C, they're having you find the hypotenuse. So if we take a look at what we have up here, question number 4 that they give us right away, question number 4, they're asking us to find C, which is the hypotenuse. So you're going to do the same thing in 4 that we just did up in 1, 2, and 3. So let's go ahead and focus on some of these other questions. I'm going to do 5 and 6 with you. As you can see, 7, 8, and 9, you're finding A or B, which means you're finding the legs. So the approaches we're going to use in 5 and 6 is the same ideas you're going to follow through with in 7, 8, and 9. So in number 5, we have the two legs making up the right angle. So A and 12 are the legs. Well, again, the formula says that those squared and then added up is equivalent to the hypotenuse squared. Well, of course, if these two are the legs, this is the hypotenuse. So the A squared and the 12 squared, my two legs squared, is going to be the same as 18 squared. All right, well, we got a couple numbers in there we can work with, so let's go ahead and work those out. We've got 12 squared, we know that one, hopefully right off the top of our heads. That's 144. And 18 squared, that's going to change into 324. So as you can see, I have now what looks like us solving an equation. What's different about most of the times we've solved an equation in this particular section is that this says A squared, and usually it would be just a variable like A or more commonly X for us, but it's the same idea. We've got to send these numbers off to the right side. Well, 324 is already over there, but 144 isn't. So let's focus on moving 144. Remember, we move something to the opposite side of the equal sign by doing the opposite. So I'm subtracting 144 all the way across now. So I've got 324 minus 144 to go here now. 324 minus 144, that's going to change into 180. All right, now remember, the side of the triangle, just like when we were up top here in 1, 2, 3, isn't labeled squared. So the fact that I have a squared here is now what my problem is. I don't need a squared. The side that's missing on the triangle is labeled a. So to undo that square, I'm going to do its opposite, square root. And again, if I have to do it on that side of the equation, I have to do it on the other. So the square root of 180 is what a is going to equal. When I do the square root of 180, the result is 13.416408786. Since my directions say to round to the nearest tenth, I'm going to write 13.4. All right, let's go ahead and try number 6. Now, number 6, again, they're looking for one of the legs, but instead of looking for A, this time they're looking for B. Remember, the legs are the two sides that make up the right angle, which are these two I'm pointing at here. So this side over here has to be my hypotenuse. Remember, the hypotenuse is always across from the right angle. So we know that these two squared, 21 squared and B squared, have to be equivalent to my hypotenuse squared, which is 29 squared. Well, we've got a couple numbers there, and again, just like the last question, we're going to go ahead and simplify those. So I've got 21 squared, he's going to change into 441. And I've got 29 squared, he's going to change into 841. All right, so let's go ahead and solve that out now. The numbers all have to go to the right. Remember, we're doing the same thing as we would do when we're solving an equation, which says numbers to the right. So I'm going to go ahead and move the 441. I'm going to move the 441 by subtracting 441 all the way across. So I do that, and I end up with b squared now being equal to 841 minus 441, or a nice even 400. Now again, that side of the triangle that we're missing isn't labeled b squared, though it's labeled b. So now what we want to do is go ahead and take the square root. So I'm going to take the square root all the way across. When I take the square root all the way across, I find out that b is 20. So side length of the triangle here, the leg, has to measure 20 units long. All right, let's go ahead and take a look at the story problem here in question number 10. Story problem in question number 10 says a glider flies 8 miles south from the airport and then 15 miles east. Then it flies in a straight line back to the airport. What was the distance of the glider's last leg back to the airport? All right, so let's make sure we're oriented with our positions here, because that's really what this question is all about. All right, traditional directions put north going up on a map. South would generally be down, east would be to the right, and west would be towards the left. So we've got the airport, and it says the glider is going to go 8 miles south from the airport. So we're going to drop down from the airport 8 units. And then once we get there, it's going to turn and go 15 units or 15 miles east. So then we're going to turn right and go 15 units. And then the glider is going to turn and fly right back to the airport. And as you can see, there is your right triangle, because here, the south and east legs, when we put those together, form your right angle. Remember, you have to have a right triangle to do Pythagorean theorem. If we wouldn't have that, this question doesn't involve Pythagorean theorem then. But since we do, that's what it's all about. Now, notice what they've given us here is they've given us the two legs, because they've given us the two sides that make the right angle. So all I'm going to do is go ahead and square these up to start, and then add. So I've got 8 squared plus 15 squared, which is equivalent to 64 plus 225. Just going to add up to make 289. And remember, when we do that, that's going to be equivalent to the hypotenuse squared. Hypotenuse is c in the formula, so that's equivalent to c squared. Well, remember, it's not c squared on the triangle, it's actually just c. So what we want to do to finish here now is we want to go ahead and take the square root all the way across. When I take the square root of 289, the result is 17. So the glider's distance from where it stops to once it turns back to the airport is a distance of 17 miles.